So the final example I'm going to speak to you about today is division. So in my other series that I'm releasing on YouTube, which is going to be looking into my research, quite often I have to measure resistance of a nanomaterial. And resistance is dependent on the length of that material. So normally the longer something is, the more resistance it has. Therefore, to be able to compare materials and resistances together, we have to what's called normalise it, which means dividing by a length, and from there we actually can compare the results independent of length. So we can actually compare if the resistance of one material is equal to the resistance of another material, whether it's greater or lower than. So quite often resistance is given the units ohms, which has the Greek letter omega as its symbol. So quite often in my research, I often measure resistances in megaohms. So I might have a value of, say, 6 times 10 to the 6 ohms, which is equal to 6 megaohms. So notice we're going with a positive exponent here. And then I'll be dividing by the length of the nanostructure that I've measured, which could be, say 200 nanometers. So let's call that 200 nanometers. And as we said in the previous examples, that is equal to 200 times 10 to the minus 9 meters, which is also equal to 2 times 10 to the minus 7 meters. So let's see what happens when we want to divide one by the other. So we're going to go with this guy, so we're going to go 6 times 10 to the 6 ohms, and we're going to divide that by 2 times 10 to the minus 7 ohms. Not ohms, sorry. That should be millimeters or nanometers. So again, in the previous video, we came up with a rule for this, where x to the a divided by x to the b is actually equal to x a minus b. So previously we just, when we do multiplications, we multiplied the numbers together. So first of all we have to divide, so we're doing 6 divided by 2, which is 3. Now we have to apply this. So again, the x is 10, so we're going to have times 10. We're going to have the a is equal to 6. We're minusing and then minusing the 7 from here. I'm just going to put a little cross across the 7 just to identify that as 7, so you don't get confused with the brackets. And then we can work this through. So 3 times 10. When you've got two negatives next to each other, that becomes a positive. So you've got 6 actually plus 7, so that is equal to 13. And then we have to deal with the units. Actually, that should be in meters, sorry, not nanometers. There we go. So we're doing ohms per meter. So this is what you'll see in my research. A lot of resistance being called normalized resistance, where you see the units of ohms per length or resistance per length. And if you've liked this video, please subscribe and hit the like button, and we'll see you again soon.